Hello, good morning, students. I hope that you all were good. Today, I will start a new topic, that is P and N type conductors. Before starting the P and N semiconductors, we should know about what is the meaning of the conductivity. Okay, so first we should know the conductivity, what it is. It is ease to flow of current, or we can say current only. Means conductivity is this thing, that the flow of current. In a simple way, in simple language, we can say electrons are moving and the current is flow easily. That is called as conductivity. Okay. According to conductivity, it is made up of three types. According to conductivity, one is conductor, insulator, and next is semiconductor. So in a conductor, what will happen? Large amount of current is produced. Current can flow easily here. In this one, those solids do not allow flow of current. Means is this, if electrons will go on this one side, then current will flow in opposite direction. In insulator, this thing is happening. What will happen in this one? Those materials in which the conductivity of semiconductors lie between conductors and insulators. Okay. The main meaning, the main motive of this one semiconductors, it come in between the both conductors and insulators. Now second point, we are telling about some example. The appliances are made up of how? In a conductors, the appliances are made up of copper, iron, aluminium. The wire of these are good conductors of electricity. All you know this thing, that wire is made up of these things. It means we cannot got any shock. Examples of this one is wood, rubber, sulfur, phosphorus, plastic. Means is this, a current does not flow easily. In a semiconductors, we are using here silicon, germanium for making the appliances. Mainly we are using here a p block elements. Here we are using a p block elements. Now one thing is very important in semiconductors. If temperature value is absolute 0, if temperature value is 0, then the conductivity is also be 0. Temperature 0, conductivity 0. Temperature increase, conductivity increase, and vice versa. So these are the differences of the conductors, insulators, and semiconductors. Now a very important point now it's going to be start, that is semiconductors is of two types. One is intrinsic conductor semiconductor and second is extrinsic semiconductor. In this one, what will happen? It is a pure. Purity is there is no any impurities. No impurity is possible. Okay. Example, we are using here a silicon, and mainly we are using here 14 group elements. Okay. 14 group elements we are using here. When we are using a 14 group elements, the valency of it is also be 4. Now one thing is very important in intrinsic. We have making this diagram of silicon. What will happen? The energy level is going from lower energy to a higher energy. Means if this bond is leaving the place, it will go on this one side. It's remain as a whole. Then it will again, here it will remain as a whole. Again it will go up, and one time it remain as a whole. So again I am telling to you, if the temperature is increased, conductivity is also be increased. And electrons are shifted. When the electrons are shifted, it leaves some hole. That was the intrinsic semiconductor. Now next is extrinsic semiconductor. Now the main point arises here. We are directly not be I will not able to directly give a lecture. Now the point starts about a p type and the n type. In a p-type, it is impure. Impurities are present. Let's talk now. Till here understood to all. Next is p-type semiconductors. What will happen? P-type semiconductors, it means P is positive. P is positive here. P-type come in excess form, means P coming in more amount. Here in P-type, deficiency of electrons then we call as positive. In this one, electron deficiency is there. Now, how we have to find out the electron deficiency is there? As we have taken a electron here. When the electron is leaving a place, it makes a one positive sign. Means positive sign, cation is coming here when the electron will leave the position. When it form a positive charge shows that it produces as a whole. You can see here also, deficiency of electrons called positive, means positive charge will produce here and it remain as a whole. It is called as a whole. Now same diagram I am using of silicon as I have used before also. Silicon, this diagram I am using. You are seeing this thing that bond is produced on both the sides. Silicon I have taken. Now silicon diagram, I am using here a normal temperature. Okay. Now what will happen here? When we are using silicon, when we are using this thing in 14 group. In a 14 group, these things are coming. Carbon, silicon, germanium, SN, PV, these things are coming. Now in a 14 group, we are adding a 13 group. Why we are adding a 13 group? Because we have to add the impurities. Okay. Because we have to add the impurities. So in a 13 group, these are the elements. These are the elements: boron, aluminium, gallium, indium and thallium. These are the impurities which is present in 13 group. And these both things are said to be as intrinsic semiconductor. One note it should be there, in 14 group, silicon and germanium behave as semiconductor. These two only behave as semiconductors. These three cannot behave as semiconductor. Now, this thing is coming from where? This thing is coming from the 14 group. But now we have to take it from the 13 group also, because we have to add the impurity. Now, same thing happen here. Now, I have made the same diagram here. But as this diagram, silicon is bond will go this side, it leaves some position. It will go this side, it leaves some position. It will go this side, then leave some position. Means hole is produced. So, same here. Hole is produced. In these holes, who has taken part? Indium has taken part. Indium is coming from which group? It is coming from the 13 group. It means this is an impurity. Now, indium has taken a part. Indium, now its valency is also be 3. Now, when its valency is 3, you can see here 1 come here, 2, 3. Now, 1 valency is left. Now, valency is not there, that's why it remain as a whole. Same we are using here, 1 valency, 2 valency, 3 valency. If 4 will be there, here 4 is not there, then also it remain as a whole here. Understood? Automatically hole create because of indium. You are seeing this thing, hole creates. Now, this hole mainly creates because of the impurities also. Because of the impurities, we are adding a 13 group. That's why. Now, till here understood to all. Now, after this, what will happen? We use all temperature, high, medium, low, then also it works. We are using any type of temperature. High also, low also, medium also. Okay. Now, when we add impurity, electron shifted. As before also, when we add impurity, electrons are shifted. Means in place of silicon, indium has taken part. In this one also, I have shown same diagram, indium one. Silicon will left its position. It will go upside, it will go upside, then also holes will be created. So overall, it can be say as electrons shifted and they form a large energy. When these electrons are shifted from lower energy level to a high energy level, then means large amount of energy is created. This we are telling about the p type of semiconductor. This is very important, p type of semiconductor. Okay, now we start now n type of semiconductor. Okay, n type of semiconductor means extrinsic. In a n type of semiconductors, group 15 we are using. Which one group? Group 15 here we are using. In that one we are using group 14 and group 13. In this one we are using group 15. Now in this one what will happen? These things are coming: nitrogen, phosphorus, arsen.